So whenever we look at triangle congruence, we're told that angle side side does not work. Now, why is that the case? So we're going to look at a couple triangles and build triangles as we go through to see what happens. So I'm first going to start with making a triangle where one of the angles is, we're going to go 40 degrees. Let's move this so I actually have my ray here. Oh, lost it. Let's go again. You're going to go angle of 40 degrees. Make the ray going through that. And then from this, I'm going to make a side along this 40 degrees. We're going to go 5 units. So I'm going to make a segment of given length from this point that is 5 units. And if I move that, I want to hit up here. So to help us, let's just make a circle. And because now that circle will be a radius that hits at this point. So now, after using that circle, and this is again just kind of the way we would use a compass to do that, this now gives us a segment or a side of our triangle that is 5 units. And we can go in and we can measure that distance. It is 5. Let's make our font a little bigger so we can actually read it. There we go. So we have 5 units, we have 40 degrees. Now I'm going to complete this triangle. I'm going to make a side coming down from here that is 3 units. So segment of given length is going to be 3. And I could swing this down. You know what? Let's go back. Let's make it 4. I could take this and I can move it down, and it's actually going to hit the triangle here, and it's going to hit the triangle here. So what this becomes is this triangle, or the setup, gives me 2 different triangles. I have a triangle that would end here with the 4, the 5, and the 40 degrees. I have the triangle that would go there, 4, 5, and 40 degrees. Now this is an angle side side. And the reason it doesn't work is it gives us 2 separate triangles. They do not guarantee the exact same triangle. It does not guarantee congruence each time. This is why we can't use angle side side as a reason. So that's why we can't use it every time. There's a certain cases that do work. So what we're going to do is, let's get rid of our starting point here. And let's get rid of our angle. So I'm going to make a new one. Our new triangle. Let's throw a point over here so I can make an angle. So we're going to go an angle this time of 30 degrees. And then that is going to give me a ray. And from that 30 degrees, I'm going to go the same setup this time, but I'm going to go, let's go 6 units this time. And so now when I move it over, I want to match it up. And just for accuracy, I'm not just going to line it up. I want to make sure it's the same length. So I draw a circle and put that point there. Hide this stuff. And another segment. Hide some more stuff. Okay, our segment we now said was 6 units. I'm going to make my other side here go down 3 units. So let's go segment of length 3. See what that does for us. Let's throw a measure on there just so we're sure. We now move this and we see it comes down and it hits the triangle, which looks like at one point. And we can check that by making the circle and then doing a point of intersection between the two, the circle and the line. And this becomes our segment. So let's hide this stuff. Our segment. And this still should be 3. Let's check. Still 3 units. But suddenly this one hits at just 1 point. So what's the difference? If I go in back and measure this angle, that where it hit, it turns out to be 90 degrees. So angle side side does work. 30 degrees, 6, and 3 gave us one unique triangle, a triangle that happened to be a right triangle. And so we're not going to use angle side side as our congruence. We're going to have what we call HL, which is a way for us to show that two right triangles are congruent.